Hi, this video is about the top 3 AI implementation mistakes. My name is David Hood, and I'm the CEO of 42 Robots AI, and we help organizations implement AI effectively. So let's see. So the number 3 mistake is, let's open that up, lack of capability, understanding of what LLMs can really do. And I'll put a link to the description below to a video talking a bit more detail about these specific things. But in this video, I'm just going to cover these real quickly. Basically, most people see them as chatbots. I've talked to enterprise organizations, and a lot of times their answer for implementing AI is Microsoft Copilot, which is a pretty poor answer and also reveals a distinct lack of understanding of how these things really work and how they can be implemented, how they can be useful. I've talked to people at organizations that do this, and they say it's pretty useless, or at least in a lot of cases. And that's because they're leaving the vast majority, at least 99% of the capabilities of LLMs on the table by doing this. There's several other things that LLMs can do, and this is not an exhaustive list. Again, watch the video to get a little bit more details about each individual ones. Semantic relevance. You can summarize text, which sounds more trivial than it is, especially when you put it within a system. And when I go to number 1 mistake, it'll expand on what you can really do with this. And then expansion of text or content. So this is not just content generation, but getting more details, digging deeper into something, as opposed to kind of the reverse of summarization. There is a whole bunch of things you can do with data processing, data analysis, data extraction, data merging. I really think that the ability to, let's just say, analyze data now with the new LLM tools that didn't exist 2 years ago is orders of magnitude more powerful than what was possible before. And just doing this in something like Microsoft Copilot or ChatGPT, however you want to set those up, or thinking about it from a chatbot standpoint, there's a lot that you're going to be missing in terms of actually enabling this to work really well. We're talking 1,000x. Just really think about the impact and how much data there is out there that's either under leveraged or it's very expensively leveraged when you can do it 1,000x what was done before. Very, very huge thing that is not being leveraged nearly as well. And that happens to be something we very much specialize in and have a lot of experience in R&D and done a lot of R&D on specifically doing that. Also, I personally have processed large amounts of data before with code, before even AI. So LLMs is just an amazing tool. Anyway, path selection, categorization, you can validate work, be it human or LLM work. These are all capabilities of LLMs that's beyond just chatbots. And there's quite a bit more. So when people go into this, they have the frame of ChatGPT or Microsoft Copilot, and it's hard. For some reason, it seems really hard for people to get out of that and understand that these are tools that can do a lot of other things. All right, we'll go to mistake number 2. If I can click on it. There we go. Lack of LLM limitations understanding. So this is kind of on the other end. This is something that where they think the LLMs can actually do more, which actually sets somebody up for failure. And this is directly relevant also to something like Microsoft Copilot. They're like, oh, we checked that AI box by doing Microsoft Copilot. They're not understanding that there's a lot that needs to be handled with regards to putting LLMs within specific workflows or specific use cases, specific solutions within an organization. You cannot just be like, all right, cool, we checked the box, now we've got AI in our company, and now we're going to move on to other things. I mean, you can, but you're not going to really get much out of that. You're just barely scratching the surface of what's possible, and in fact, in a lot of cases, you're probably just you might actually be making a net negative scenario because you're creating extra weight, extra work for other people that doesn't really help them at all, or might actually get to be a net negative. So again, there's a video. I'll put a link to the video below about the limitations of LLMs. Please watch that for more details, as I'm just going to kind of power through these pretty quickly. And again, this is not an exhaustive list. There are several other things about LLMs that are that create limitations. So the fact that when you're running it at inference, which is basically when you try to get a response from an LLM, it's doing next token prediction. This in and of itself creates significant limitations and is the reason for a lot of the other problems that it has. And hopefully that, to me, that's really obvious why if you just do one token at a time, that can create all sorts of issues. But for some reason, some people still think that with next token prediction, you can get like an AGI out of that, or like a super intelligence, and that to me doesn't really add up. So another really important distinction is thinking about what LLMs can create. They can create new recipes, but they can't create new ingredients. This is a really tough distinction to make because it's like there's a little bit of a discussion out there, but like, can they make new things? Can they come up with new laws of physics? And the answer to that is that if it requires recombining some of the pieces that we've already fed into it into new ways, then yes, which is new recipes, then yes, it can come up with things. But if it needs to come up with a new ingredient to make a recipe work, then the answer is generally going to be no. So for example, with like protein folding, AI is really good at that because we kind of have the base ingredients. It's just about there's like a gazillion different recipes and ways to kind of model testing that. But if there was like a new element, or maybe a new state of matter, or a new law of physics that really that didn't have all the ingredients somewhere else in something we already know about, but it required making up one or more new ingredients, right now LLMs will not come up with that. They just won't. That it needs to be basically in their data set. They are, at its core, an LLM is basically an imitation engine. Now, yes, you can create steampunk, Harry Potter romance novels, right? But again, that's just taking the ingredients that we already have in our lexicon as humans and recombining them. So hallucinations / creativity. This is a bug and a feature. It depends on exactly what you're trying to do. Now, when you're trying to fit this within like an organization's solution, this generally is a bit of a negative. Again, it depends on exactly how you're using the LLM. So this is a limitation, and a part of this is that again with the next token prediction, part of it is it's got some randomness into it. It's not just what's the most likely next chunk of text, and then we're going to use that one. No, it has a distribution, and sometimes it picks a low probability, which can kind of send it off into La La Land, where you don't want it to go. There's reason to believe that even though it mimics true understanding, that it actually it doesn't truly understand. And this is a little bit of a philosophical argument because some of this is kind of how our brains work to some degree. So maybe we don't truly understand, but there's good reason to believe, and there's several use cases, and I won't go into them here, that imply pretty directly that yes, actually, it does not really understand. Again, it's mimicking, you're giving it a pattern to start with, a seed pattern, and it's going through its data set and its training and everything, and it's finding the most common pattern to respond with. And if somebody else out there has understood it, then it's got that in its data, it can essentially mimic that understanding. And along the same lines, reasoning. Is it actually reasoning? And I think in general, again, the answer is no, but it's a little bit of a philosophical question as well. And again, I think that it's mimicking reasoning in general. Now, we look back at the recipes versus ingredients, it can actually kind of come up with somewhat novel reasoning or mimicking or having some sort of novel understanding. And that's because potentially you're actually creating new recipes, but you're not actually creating new ingredients. So the ingredients for the understanding and the reasoning are there, and so it combines them together in potentially a new way that is actually useful and novel in certain sense, but it's not necessarily, again, depending on how you define true understanding, true reasoning, it's not actually there. Surprisingly, they're not good at math. In all the past, it's always been AI is like, oh, super good at math and bad at emotions and language. Well, these are language models, so they're not really good at math. And part of this is also, it's actually an inevitability. Inevitability. So if you have an LLM, and part of this is next token prediction and hallucinations and all sorts of other things, and you try to like run it in a loop, and to where it kind of does its thing for a long time, without a human kind of guiding it, inevitably it will go off the rails. And that is because eventually it'll start picking tokens that are unlikely or that are just incorrect, and it just made a mistake, and it just goes further and further off the rails to where it gets more and more nonsense. This is why the Devin video, why it's fake, and why you can't just like have it be like, all right, write me this software system that's really complex and just do it iteratively and set it on go and come back 24 hours later where it runs 10,000 iterations. What you'll get is a pile of garbage, and every iteration beyond the first few, it becomes more and more garbagey. It does not do long-term memory. I feel like within our company, we've built something that does, at least according to my testing, does solve long-term memory, but it's not within the LLM itself. And to me, it's folly to try to put it within the LLM, because it costs 1 million times more if it's even solvable at all. While within our organization, I think that at least the core of the solution, and we haven't proved this beyond a shadow of doubt, but to me, I've demonstrated it. But I believe that we have actually solved it pretty quickly with less than a week of coders' time, because we thought about it in a more practical way instead of trying to embed it inside the LLMs, which again is kind of folly. And when you think about it, LLMs are still about the same 500 lines of code that they were when they came out in 2017. So they haven't really been able to improve the core technology of LLMs that much. It's just been mostly doing stuff with the data and the way that they train it. And that's it. Okay, so number one mistake, by far and away, bad AI solution architecture. And I'll put a link to this below, but this is just so pervasive. It blows my mind how few people, how many people are building on a bad framework. Basically, if your solution is based upon is basically model centric, then it's wrong. And probably 95 to 99% of use cases. And this is part of why using Copilot doesn't work, because it's just an LLM centric solution. And you can see the way that people talk about, and they don't necessarily say these exact words, although I have heard people say these things. The solution is the model, and the model is the solution, or the product is the model, and the model is the product. I believe OpenAI said that. You can tell the way they talk about the solution where they're using the words model and solution or software interchangeably. And this is incredibly common. And it is also incredibly limiting. You are leaving 99+% probably, at least 95, and probably more like 99% plus of your solution space on the table if you do this. This is such a huge mistake, and it took me a long time to realize that it was a mistake that people were making, because to me, it's been obvious since the middle of 2023. Painfully obvious, and I thought more people saw it. And it took me a long time to even just figure out why. I didn't even completely understand it. I think I'll tell you why in a second, and then I'll give the correct architecture. But really what this involves is shoving as much of the solution into the LLM as possible. And this is suboptimal. The LLMs just don't work that well in that way. And especially you go back to the limitations and understand the capabilities, and that will help kind of lead to the right architecture. All right, when you end up shoving as much into the solution as possible, you can't just keep adding things. Oh, it does A and B and C. Now let's add D. Okay, now let's add E. That's not how it works. When you add D, you actually potentially reduce its effectiveness at A. And then you add E, and now you make A even worse, and now B is worse. You play whack-a-mole with the issues when you try to shove it all into there. It doesn't work. It can work, but in general, it's very, very suboptimal. So why is everybody, this took me forever to figure out, why is everybody doing this? First of all, you have a bunch of nerds out there, tech bros, who are like, my robot friends are here, great, fantastic, I'm in love. And so they're seeing what they want to see. Also, along similar lines, there's just a general lack of interest of taking the solution outside of the new magic toys. Again, the boys have the new toys, the nerds have the new toys, and they just want to play with their new toys. I've even heard some computer science people kind of in an interview, they started to kind of go very briefly towards building the correct architecture, and he was like, he stopped it. He was like, no, but that's not interesting. That's no fun. And it's like, okay, I mean, I guess if your purpose here is to have fun instead of actually doing practical work that helps humans, then sure. But if you really want to think about this, how do I actually solve real world problems? That should not be the determining factor. And there's, again, along the same lines, there's a lot of groupthink here. And I think there's just, it's a lack of practicality. It's also a lack of systems thinking. Again, you have a bunch of computer engineers who, or like AI engineer, no, not AI engineer, machine learning engineers, computer scientists with PhDs who don't really understand how to fit these within real world scenarios. And they're just trying to solve these kind of hypothetical problems that are very interesting and that sound more fun. And also, there's a vested interest in making these solutions very model-centric. Again, selling Copilot. Microsoft's making a crap ton of money selling Copilot into these large organizations as this is your AI solution, when it is not. And also same thing for ChatGPT. All right, so I'll go into the correct architecture. Definitely watch the bad AI solution architecture video if you want to really get a little bit deeper in this. So the correct architecture is not to think of this as an LLM that has a little bit of stuff around it where you train, you prompt engineer, and then you have some tools that's like classic code that kind of helps it in certain places. The correct way to think about this is just software. I know it's boring and it's not as interesting, but it is so much more practical, where within the software, use LLMs as tools to solve key problems that you couldn't solve or that were very challenging to solve without LLMs. And you actually want to pull as much at each step, you want to pull as much out of the LLM, as much of the solution out of it, and only use the LLM for the part that you absolutely need it for, instead of putting as much as you can into it. What this does is this lowers the main thing that this does is it increases the reliability, which within a business organization, if you have a business process, this can be extremely important. And this is part of the challenge with, again, just using like ChatGPT or Copilot. You are sitting there and you don't have a reliable process. You have something that's built to be super general in a lot of different ways, and there's no way to and you're very limited as a user in your ability to kind of tune it to make it fit for what you're trying to solve. But what a better way to do it is when you tune it for a very specific thing. It's like, okay, I cannot do this with classic coding. I need to use AI at this specific step. Now what I can do is I can use a lighter model, a faster model, a cheaper model, and then you can make the process much, much more reliable to where you can actually get a good result out of it. But also by pulling it out and picking it apart, so you're not just relying on an LLM at one key step, you're using it at maybe multiple, like dozens of steps. What you end up with is you can get a much more reliable output on the other side. And this is the reason, I think, why I hear a bunch of people saying, everybody's struggling with AI agents. Everybody's struggling with AI agents. Because they're building it with an LLM architecture. I heard somebody who's very big in this space say, AI agents are basically LLMs on a loop. Which is yeah, you can try that, but that is not going to work for you in 99+% of the use cases. AI agents are software that use LLMs at a minimum to make decisions, and probably also for some sort of chat. But also, just like I think a lot of other software, non-agent software, needs to be, in order to improve upon it, you need to put LLMs in there as tools to solve key problems, to improve its functionality, and all sorts of different stuff. Within these agents, you're probably using LLMs in other ways as well. So that's not a requirement, but in general, I think an AI agent is something that kind of makes decisions, where you let the AI make some sort of decisions. I don't think it has to have chat, but it could. But at a minimum, it makes decisions. But again, it's just software. It's software that is classic coding. This is non-random coding that uses LLMs as tools in key places. That's what an AI agent is. All right. If you would like to actually avoid these mistakes that can be very costly and waste a ton of your time and money as an organization, contact us today for a free custom AI implementation roadmap. You can call this number, or you can click the link below. If you like this video, please like and subscribe so other people can hear the good word here of actually building real world solutions that really help humans and aren't just fun play toys that write poems that don't really help anybody. Anyway, thank you very much. Have a great day. Bye.